Hello students, today we'll discuss solid geometry questions, and for this you can use the calculator. So let's begin. Pause the video and try solving this question, and once you have an answer come back and check. The sum of the lengths of the 12 edges of a rectangular box is 140, and the distance from one corner of the box to the farthest corner is 21. The total surface area of the box is. So if you draw a rectangular box, then let's say this is the length, this is the breadth, and this is the height. So the sum of the 12 edges would mean that it's 4 times L plus 4 times B plus 4 times H. That is given as 140. So I can say that L plus B plus H is 140 by 4, which is 35, right? So that's one equation that I have. And the distance from one corner of the box to the farthest corner. So let's say from here to here. How do we denote this distance? Let's change the color. This distance. This distance, the extreme nth distance, in the case of a rectangular box, is given by d, which is also known as the body diagonal, is the square root of L square plus B square plus H squared, right? And this distance is given as 21. So I can say that L square plus B square plus H square is 21 square, which is 441. So I have these two equations, and the question now is asking me to find the total surface area of the box. So I know that the total surface area of a rectangular box is given by 2 times L into B, because there are two faces whose area is L into B, plus 2 times B into H. Again, there are two faces with area B into H, plus 2 times L into H. This is the total area. Now, how can I find this area when I have the sum of L, B, and H here, and I have the sum of the squares here? So for this, we'll use a formula. The formula is L plus B plus H the whole squared, which will be L squared plus B squared plus H squared plus 2LB plus 2PH plus 2LH, right? So we find that the square of the sum of the three dimensions is equal to this. And this is what we need to find. So we can say that total surface area is L plus B plus H the whole squared minus L square plus B square plus H square, right? So that will be, what is L plus B plus H the whole squared? That is 35 squared, and L square plus B square plus H squared is 441. So if we plug this in the calculator, let's do that. What is 35 squared? 35 squared comes to 1225. So that is 1225 minus 441, which comes to 784. And so my right answer is option B. Okay, let's go to the second question. A right circular cone of volume A. So let's draw a right circular cone. A right circular cone of volume A. So this volume is A. A right circular cylinder of volume M This is a cylinder and its volume is M, and a sphere of volume C. This is a sphere of volume C, have the same radius. Okay, so this is R, this is R, and this also is R. They have the same radius, and the common height of the cone and the cylinder. So both the cone and the cylinder have a common height is equal to the diameter of the sphere. So H is equal to 2R. Then what is the relationship between the three volumes? That's what we have to find, right? So the volume of the cone, which is A, will be 1 by 3 pi R squared H, which is 1 by 3 pi R squared into H is 2R. So this is 2 by 3 pi R cube. Okay, that's the volume of the cone. What about the volume of the cylinder M? M will be pi R squared H, which is pi R squared into 2R, which is 2 pi R cube, right? And what about the volume of the sphere, which is C? That's 4 by 3 pi R cube. So we have the three numbers. A is 2 by 3 pi R cube, M is 2 pi R cube, and C is 4 by 3 pi R cube. So let's try and work out what could be the answer here. Let's see what A plus M is going to be. So A plus M is going to be 2 by 3 pi R cube plus 2 pi R cube, which is 8 by 3 pi R cube, which is 2C. So I can see that A plus M is going to be 2C. So I can cancel out B. Okay, what about A plus C? A plus C is going to be 2 by 3 pi R cube plus 4 by 3 pi R cube, which is 6 by 3 or 2 pi R cube. And that is indeed equal to M. So A plus C is equal to M, which means my right answer is A. Right. Let's go to the next question. Now, there's a circular pipe with inside diameter of 1 inch. So there is a circular pipe with inside diameter of 1 inch. So this diameter is 1 inch. And another circular pipe with inside diameter of 6 inches. So there is another circular pipe and its inside diameter is 6 inches. Both the pipes have the same length. So the length is the same for both the pipes. Let's say the length is L. How many 1 inch pipes will carry the same water as a 6 inch pipe? So what is the volume of the 6 inch pipe? It's pi R squared H, which is pi 3 squared L, which is 9 pi L. And what is the volume of the 1 inch pipe? It's going to be pi 1 squared. No, 1 is the diameter. So pi 0.5. So let's change that. Yeah. So that's pi 0.5 squared into L, which is 0.25 pi L. So the amount of water that a 1 inch pipe will carry will be 0.25 pi L, and the amount of water that the 6 inch pipe will carry is 9 pi L. So how many 1 inch pipes will carry the same? That value will be 9 pi L divided by 0.25 pi L. which is 9 into 4 or 36. So 36 small pipes will carry the same water as one big pipe.